Well, yeah. I just put that piece of metal. It was all one piece, and I just put up there in that vise there. Took a little while to do it. Sawed in two. That's an 18 tooth blade right there, but I believe it's a Lennox. I done wore the paint off of it, so I'm not sure on that. But it's a pretty good blade there for cutting aluminum. You know what I mean? Going for the extra point, I would say. But made that in one piece. That's a compensating valve right there once we get it finished up. Let's go over there and get that done. Okay. This is what we ended up with from that hacksaw going on over there. A little scratching from the. It's my cutoff tool. I need a cutoff tool that I can actually use. The one I got's just too flimsy. Just saying. But the project at hand here is, if you may indulge me, you might learn something. Get a pad and pencil, take notes. You know, build yourself one little item to have there on the desk. Somebody come in and say, "What is that?" You can say that right there is you can say that's one of them compensating valves for a well. International M Type M engine. McCormick Deering, you know, had the same thing in it, but right there's that's the little item that we're making here, and it's inside this. So I needed 4 of them, so I just figured I'd make them in pairs. So I cut a piece of metal, total length of that right there, put it in the lathe over there, and I done turned half of it on this side. So now I'm going to chuck this back in the lathe and turn the other side and drill a hole into it to match the one I've done started on this side for a pilot hole. And that hole in there, let's see. Let's note that on our print right here. That hole right there is drilled. I'm just going to put it right in the. I think it's a pass, okay. I'm just going to put a 1/4 inch right there. You know, I could come over here, and I probably should do it. And I'm going to put some little dotted lines right there, and I'm going to put air to it, and I'm going to go up like that right there, and I'm going to put, I'll show you this, 1/4 drill bit. So that'll give the right amount of clearance for, I'll show you. That's where that goes at in there, back and forth. Now I'll show you something interesting on that too. Kick back and take notes. But with the 1/4 inch drill bit just in yonder, that's a real nice sliding fit going to be on that shaft that goes through there. Okay, this is an original one for a kerosene engine. It's a 3 horsepower Type M, and let's put 3 horsepower over here for sure, and 3 horsepower. So don't forget that on this size here. They're smaller in the other engines or bigger in the other engines. So You know, taking the caliper and all to it. You know what I mean, on the outside right here. You know, like it right there. Run that. That's 1.486, and you can see I done already penciled in there 1.485. So we're going to stay with that number there. That's on how big it is round, if you're making one. And on the thickness on this face here is 0.0935. Oh, it went to forward in, so it's kind of iffy. 0.94. Okay, checking the print here, I've already, when I wrote these up, it's 0.094. So that's how thick this one is. Okay, this one right here is, I'm not sure if it's early model or late model, but this compensating valve is made out of metal, and it's original international, but it's a thinner metal right there. That's that's only 0.060 on that right there, and it's got a piece of metal tube in there, and it was pressed together there, and it worked. You know, it was in an engine. But interesting, I'll show you something. This is too many holes in a compensating valve if you're going to run gasoline in it. This is for kerosene only, with all them holes in there. They were kerosene engines, and even McCormick Deering, you know, International McCormick Deering later on, in the engines that was totally gasoline, you know, they only have 2 holes in there. So the engineers up there at Milwaukee or Chicago or wherever it is, Chicago, were smart enough to know this was too many for gas. So, you know, they changed it. And so if you're building one, you should do that. If you're rebuilding an engine and you don't intend to run kerosene engines in it, then you should modify this. So, and this right here was in an engine that I took out of 3 horsepower that I have taken apart. And evidently, the person that got that engine running, this was missing. So he made this in his shop. And it's quite ingenious. It's just a carriage bolt, 1/4 inch comes through there, got a nut on it. And it's a big fender washer there. And a spring it's a little on the tight side, but it's close. And then up here on the other end right there, what they did for the compensator here, to copy this part up, they have taken a big thick washer, solid washer, and put a little washer in the center of it, and then welded all that together, and then they drilled 2 holes in it. So they must have knew that that all amount was too many. There is another hole over there, but I think that was in the piece of metal they used. But anyways, the ingenuity that you can do to get these engines running without any machine work. So, and I've already made the new shafts to go in there, and that's that part in the center there. So let's get over there and turn these to size. And the project is to get this out of this when we get done with it. And the other dimensions, which probably kind of important, I guess, the whole total length from one end here to the other end right there, looking at it sideways, is 1.360. That's across yonder. Okay, that's 1.3605. So we're going to stay with that number. The outside of this this part right here, it's 375. So on average, Yeah, 372 there on that one. And then this other one over here, it's 372.5 on that side and 386 on that side. So it's forgiving on the outside of that, but and the way that works is this spring would ride against that on this shaft right here, and it sits there and moves backwards and forwards. That's all that does, and it moves quite a bit. This is the one I removed this. These two parts right here I removed from this engine we were working on. And I was thinking that this thing right here probably didn't move very much, you know. It just probably moved a very little bit, if any, when it's sitting there idling especially. Well, I think it moves more than that, but I don't know what the engine was ever used for. Taking that in consideration, I'll show you something that's interesting. Because if you put the thing back on that shaft that it rides on, noting the wire right here undercut is quite deep. Up here too, it's probably 10 thousandths, and down here that's 10 or that's a little more, I would think. And it's offset to the shaft's levelness. So, and if you push this back to where it would have bottomed out on the wire shoulder, and then pull it forward to where it would wear out on the front shoulder as its normal closed position. So when it calls for a gulp of air, when the intake valve opens and it requires air, this thing has to move. And I thought it only moved a little bit. But looking at the wire pattern on this shaft right here, that is... it's more than 1/8 of an inch. Let's see what that is. Let's do it the other way and I can get a tape measure up on it. A 6-inch ruler. Okay, I'm going to bottom it out. I'm bottoming out on this part down here. And then right up here is that's the part we want to measure. And it's 3/16. That's how much this compensator moves on that shaft in its normal daily life. And the amount of wire right there. Now, taking in consideration that when you put the spring on here, the spring is usually biased to one side or the other as to the pressure, which could account for it. But the compensator has to move that much to do that spring pressure in order to move that much right there. That's a lot. So just keeping that in mind when you're thinking about adjusting this, how important this is what I'm saying. And especially that it has a good seat for this to ride on. It's almost required. Okay, what we're going to do is in the face of this one, this being the center of it right there like that, instead of drilling all them holes in it, I'm going to drill 2 1/4-inch holes, one on each side there in the milling machine, on a circle there across from each other. And that'll be plenty amount for a gas engine. Let's get on with that. I think that'll be good enough. Now let's go over and drill a couple of holes in it. We'll turn that in for grade. Let's make another one. Painting some parts over. In the meantime, that Rust-Oleum green, dark hunter green, 3 coats of green I done put on that there engine over there. She's good to go right now. We'll get some decals on there in a day or so. But I'm going to turn this in for grade here. A little recap, so to speak, and kind of tell you something that I learned through the years, you know, fooling with these old engines, that, you know, most carburetors is about 3 times too big for whatever engine that they're on. You know, just write that down on the wall over there. Through some higher level of education learning, I'm going to turn these in for grade. That's what we just made over there on that grizzly-lathe. This is the original one here. It's got too many holes in it. And the plan early kind of, well, just imagine this and we'll talk about that. This was the project. To make one of these, I need 4. So my thinking was, on this piece of metal, that's 1.5 inch, that's 60/61. It says precision rod on it there, kaiser-select, and it was. You can see how it worked. So that was the need, was to make 4 more of these. So my thinking was that I would like to chuck this long piece in the lathe to turn the end. So I imagined that there was one of them inside that piece of metal right there, and that there was one in this piece of metal over here. And I marked it off right there, sawed it off, and then I turned, recap on the video we just watched, the end of it looked like that. And then I took it out and turned it around and did the other end. And then I sawed it half in two and then put this in the lathe and then turned that part. You know, country boy logic. Simple deduction. And you see there's only 4 holes here. And the original print that I had kind of drawn up there was 2 1/4 inch holes. Well, as I was giving it some more thought, I decided to go with 4 3/16 holes is what we got, as compared to the 8 for the kerosene engine. If you're going to run kerosene engine, then this is, well, it's still too much, but it's good for a kerosene engine. So this engine will always run on gasoline from now on out. All of them will. So the modification is, and the thinking behind it for confirmation is, the later spark plug M's, the compensating valve, only has 2 holes in it. Well, on this 3 horsepower, I opted to go with 4 3/16, which just cut it down half amount. So, but this is, doing this modification to these mixers is, I tried it one time on an idea and it actually worked. You know, it proved to work. But I'm going to turn these in. I'm going to turn them in for grade right there. You know, I kind of do agree with the stamping on the piece of metal, Kaiser-Select. I do think it's a better grade of aluminum, but this outcome, and this is the print right here we're going by. And a couple upcoming projects is to make some of these square covers for this right here. Going to make them out of some like 12L or 14L. And also some of these plugs here to go in that side over right there. Need several of them. But the way this, the simple way this is, and you see I got them new choke plates made there. So, but one of the most important parts of this engine is that seat right down in there that this compensator rides against. It bottoms out against that seat. And if you're making one of these, you have to keep mindful how long this short end is, that it don't hit the back of that bracket and prevent it from closing. But the simple way and the way it goes, that's a 1/4 28 on that thread there, and that's a real nice sliding fit. So well, that's really good. So we'll have no problem here. You can never blame that on any kind of problem. But the simple and easy way to know that works, and that it does look good down in there, is we'll put this in from up here, and then you put this compensator in there like that right there. Drop it down in there, and I done cleaned that up and everything, and checked it out. And the spring, and the rear cover, and it's got an indent in it for the spring, and then that's got a protrusion on that for the spring. But that's all the parts they are to that. And a 1/4 28 nut on here. See, Yeah, and you tighten that up, and it's wise. It's a good idea to put some Permatex around here. I'll take it back apart and do that around here before you bolt that up on there, because if it sucks air here, it's not making the compensator work. But and to test it, you just, oh yeah, oh, that's gonna run good. And it now is set up for gasoline now, so it shouldn't have to run any choke open or closed or anything. Oh yeah, I'm gonna turn it in for grade. Leave a comment.